Have you ever wondered how the touch display on your phone works? These touch displays or touchscreens are more than just a shiny surface. They're an integral part of our modern lives, controlling everything from our smartphones to self-service kiosks. They're the magic that lets us navigate the digital world with a simple swipe or tap. In fact, touch displays have revolutionized the way we interact with our devices, making technology more intuitive and accessible. Now, you might ask, how do these touch displays actually work? The majority of today's devices use what's known as capacitive touch displays. These cunningly crafted devices offer an intuitive user experience by harnessing the body's natural conductivity. You see, every time you touch the screen of your smartphone or tablet, you're interacting with a complex system that's designed to detect and react to your touch. There are two main types of capacitive touch displays: surface capacitive and projected capacitive. Surface capacitive screens utilize sensors at the corners and an ultra-thin uniform conductive layer to detect a touch. On the other hand, projected capacitive screens, the ones most commonly found on your smartphones and tablets, use a matrix of rows and columns with a separate chip for processing. This allows for multi-touch functionality. Think pinching to zoom into a photo, or using multiple fingers to play a virtual piano. That's the basics of capacitive touch displays, but there's more to it than that. So, how does a capacitive touch screen register your touch? Well, let's dive into the fascinating world of science that makes this possible. You see, capacitive touchscreens are not just a single layer of glass, they're a complex sandwich of multiple layers. The outermost layer is a protective glass, followed by a capacitive layer, then the device's display screen, and finally a back layer. The magic happens in the capacitive layer, where a constant electrical current runs across the screen. This current creates an electrostatic field which is invisible to the naked eye, but is the secret sauce to the touch detection process. Now, imagine you're about to swipe right on your phone. The moment your finger, which is conveniently also an electrical conductor, comes into contact with the touchscreen, it distorts the electrostatic field at that specific point. The device's processor detects this distortion and calculates its exact location based on the strength and distribution of the electrical charges. But what if you're wearing gloves or using a stylus? That's where capacitive touchscreens show their true genius. They're designed to respond to anything that holds an electrical charge, which means that even your favorite pair of winter gloves or your trusty stylus can interact with the screen as long as they're capacitive. The processor doesn't just stop at locating the point of contact, though. It also measures the extent of distortion to determine the type of touch. A light tap will cause a smaller distortion than a hard press, allowing the device to distinguish between different levels of pressure. This is how features like pressure-sensitive drawing and 3D touch on iPhones work, and that's it. The processor sends this information to the operating system, which then triggers the appropriate response, whether that's opening an app, typing a letter, or zooming in on a photo. And just like that, your touch is registered, allowing you to interact with your device. Capacitive touchscreens aren't the only type out there, though. Let's take a quick look at some alternatives. First up, we have resistive touchscreens. They operate on pressure and use two electrically resistive layers. When you press on the screen, these layers meet and create a change in the electric field. The device then interprets this as a touch. However, they are less responsive and provide lower clarity than capacitive screens. Next, we have infrared touchscreens. These use a grid of infrared light beams. When you touch the screen, you interrupt these beams. The sensors then detect this interruption and interpret it as a touch. But the accuracy of infrared screens can be affected by dust, dirt, and direct sunlight, making them less suitable for outdoor use. While these alternatives have their uses, capacitive touchscreens with their high sensitivity and clarity have become the industry standard. So, now you know how your phone screen knows just when and where you're touching it. In a nutshell, that's how touch displays work. We've journeyed through the fascinating world of capacitive touch displays, delving into the basics and the science that powers them. These screens, with their ability to sense the minute electrical charges in our skin, have become an integral part of our daily lives. We also explored the alternatives, showing that innovation in this field is far from over. Next time you swipe your phone screen, remember the impressive technology that makes it possible.